I'm Matthew Cathy, and today we are going to talk about synthetic division and polynomials. In order to divide a polynomial utilizing this synthetic division method, the divisor that you're using must be a linear expression, and the coefficient must be 1. If not, divide the expression by the leading coefficient. For example, 5x plus 1 would become x plus 1/5. Then to set up the problem, first set the divisor equal to 0 to find out what number you're going to put in this little division box here on the left side. So for example, we have x minus 3. So if we set that to 0, then we get x equals positive 3. So we'll put a positive 3 in the division box. Then we're going to look at the coefficients on the polynomial, and we're going to write them in a row, okay, across the top. So for example, x third minus 5x squared plus 3x plus 7, we will have 1, negative 5, positive 3, 7. So just write them in a row as you see here. Now, you want to be mindful of if you the exponents are in descending order, and if you are missing one, for example, if the x squared wasn't here, if you went straight to the 3x, you would put a placeholder or a 0, you know, there, where we now have the negative 5. So otherwise the problem won't work. All right, the next step is now you're going to bring the leading coefficient down, and in this case we have 1, and so you're just going to draw a little arrow and you're going to put it down underneath the line at the bottom. All right. Next, you're going to multiply the number in the division box, which is our 3, and you're going to multiply it with the 1 that we just put down. 3 times 1, and that's going to be 3. And that 3 you will put in the second column underneath the negative 5. Okay. So it's probably easier to look at the example that I have. That might explain a little bit. It's kind of easier to see than explain. All right. Next, you're going to add this second column that you just wrote down of numbers together, and you'll write the answer directly below under the line. So we have negative 5 plus 3 equals negative 2. So you'll put a negative 2 under there. All right, then you're going to multiply the 3 by the negative 2. That equals negative 6, and so you will put that under the third coefficient, under the 3. So it will be, and then it will be 3 minus 6 equals negative 3. And I don't know if you can guess what we'll do next, but you're just going to keep repeating the steps till you get to the end of the problem. And so we will then, 3 times negative 3 equals negative 9, and so the negative 9 will go underneath 7, and then 7 minus 9 equals negative 2, okay? So negative 2 is going to end up being part of our remainder. So it will be negative 2 over that x minus 3 will be the remainder. So then you, in order to write the final answer, it is made up of the numbers in the bottom row with the last number being the remainder, okay? And the x's are variables. You're going to, when you write the answer, you're going to start 1 power less than the original, and then you'll write them in descending order. So we were left with, we see a 1, a negative 1, a negative 3, and a negative 2. So that 1 now will become 1x squared, because we remember we originally started with an x cubed. So it'll be 1x squared minus 2x minus 3, no x, and then remainder negative 2 over the x minus 3, okay? Now, in this case, if we were doing it, I'm going to do another video on rational root theorem and how to find roots or zeros from polynomials. And in that case, you would go back and try something else, another number, because the negative 2, if you had a 0 there, then you could use that as a root or a 0. That's negative 3 with that 3, but we can't. So anyway, I am going to do another video on rational root theorem, and that sort of is the part A to this part B to some of the things that some of the classes are doing. So anyway, I hope this made sense, and I hope do look at the examples, and anyway, let me know if you have any questions.